Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which helps us in printing root to leaf paths of a binary tree one per line. First, let us see an example. As you can see, there are three root to leaf paths in this binary tree. The first one is from node 1 to node 4. The second one is from node 1 to node 5 and the last one is from node 1 to node 3. Now, let us have a look at the algorithm which will assist us in this. Let us also have a sample tree to test our algorithm. We have a path array to store the path. From print paths function, we pass the root node, the path array and the path length which will be initially 0 to the print paths recurve function. Since node is not null, we append this node to the path array. So the first element of array path will be 1. Also, we increment variable path len by 1. So, path len will now be equal to 1. We check if node is a leaf node or not. Since 1 has both left and right child, it is not a leaf node. We move to the else part. We recursively call the left and the right subtree using a call stack. First, we pass 1's left child to function print paths recur. So, node will now point to 2. Since node is not null, we append 2 to array path. Now we increment path len. So, path len will be equal to 2. Since 2 is not a leaf node, we go to the else part. Now, we pass the left child of 2 which is 4. Since 4 is not null, we add it to the path array. We increment path len, so path len will be equal to 3. Since 4 is a leaf node as it does not have left or right child, we print the path that led to this node. So we print the path array. After printing, we continue execution for node 2. The path len for node 2 was 2. So, path len will now be equal to 2. We move on to the right subtree of node 2. So, 5 is passed to the function print paths recur. Since node is not null, we add this to the path array. Also, path len is incremented. We check if the node is a leaf node or not. Since 5 is a leaf node, we print the path that led to node 5. So, 1, 2 and 5 are printed. We finish execution for node 5 and node 2 as we have traversed both the left and the right subtree. We continue with node 1. Now, we move on to the right subtree of node 1. So, 3 is passed. Since 3 is not null, we add 3 to the path array. Also, we increment path len. Next, we check if 3 is a leaf node or not. Since 3 does not have any child, it is a leaf node. So, we print the path array. We finish execution for node 1. We have the final output. Now, let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here, n are the number of nodes in our binary tree. With this, We come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.